Okay, so let's conclude the chapter as it is, and then I've found some material that looks at the modern times over East Africa in terms of climate variability and change and vegetation response. That gives us a good sense of how complicated this issue is. So that means two things. One is that the simple model that's used for the long simulation has to be considered in that light, that it has doesn't resolve those small scales. The other is that maybe when we look at issues like how hominins responded to climate change, vegetation change, landscape change, they wouldn't really worry about small scale changes. They can adjust better to small scale changes, but they would have to worry about larger scale changes. So in that sense, the model is adequate. So we have to just accept this as a way of doing things. So zooming out again to the global to close out the chapter from the book before I add the vegetation part for the modern times. Global aerial barren ground coverage anomaly at 60,000, 48,000 and 38,000 years from the long simulation. Now you can see many more colors moving northward here all the way into the northern end of the Eurasian landmass. So 60,000 years ago minus 1800 barren ground aerial coverage difference. So barren land expanded significantly around this time, and you know that the European colonization, Neanderthal conflicts and so on began to happen around this time and a little bit later towards this time, for example. So those are the sites again, Lake Malawi and Kebara. And there are at the same time reduced barren land aerial coverage over Africa, over Asia and Australia. So Australia northern end has the monsoon regime. The center is mostly dry and barren, and there are also vegetated lands over here. So this is a loss with respect to 1800. So obviously 1800 has more vegetated area, less barren land compared to 60,000 years ago, and you can see that's the same case into 48,000 year and 38,000 years as well. And this pattern, horseshoe pattern, is kind of interesting, almost like the outer edge of the continent, which makes sense because this is also a warmer, wetter region, even though there is not much upwelling happening here. Relatively speaking. So this region here, because of the trade winds, East African region and Eastern Pacific, West African region, Eastern Atlantic region and Eastern Pacific regions are very rich upwelling fisheries places, whereas this one is not because of the Indonesian through flow and the related dynamics, but temperatures are still pretty warm. So you can see maybe this loop here makes sense in terms of the climate and the vegetation response associated with it. Okay, so obviously these begin to make sense in terms of potential impacts on hominins in terms of expanded barren lands and how they would have provided a barrier to various movements of modern humans into Neanderthal areas and so on. Global next one up is global area vegetation coverage anomaly for broadleaf trees, now getting to 50,000. Also net primary production and aerial vegetation cover for broadleaf at 30,000 years and net primary production for the same time. Also look at this from the long 122,000 year simulation. So broadleaf area coverage, the signal is very spotty, but similar to what we've seen before, but you can see South America and North America begin to show up more when we zoom out here. 50,000 to 30,000 years ago. This signal is not something we saw before. So something that changed here in terms of the Pacific dynamics, maybe hurricane dynamics here, and so on, and this spotty coverage here into Southeast Asia and southern part of China and so on, and Africa are all here. So this is the broadleaf area coverage. This is the net primary productivity difference. So again, as before, the reduced aerial coverage is not as significant as the reduced net primary productivity compared to 1800, and that's also true here. So in the model, obviously there is a dynamic which is computing aerial coverage difference, and so even though aerial coverage didn't reduce much here and here, net primary productivity reduced quite a bit. So we'll look at this from the modern times a little bit to see if we can understand that, and this is true also here in this region. Hardly any change in aerial coverage from the model simulation, but there are signals of net primary production. 30,000 years ago, similar changes. So some changes in aerial coverage of broadleaf trees, but significant drops in or much larger drops in net primary productivity compared to 1800. Again, we don't know how this would have affected hominin diaspora and so on even here. And we have talked about the Clovis and the coastal path and the interior path during more recent times, but this time scale may end up changing as well to see exactly when our ancestors made into these regions. Okay. Global aerial vegetation cover at 22,000 years, broadleaf trees, needleleaf trees, C3, C4 from the long simulation. So broadleaf generally decreasing in lots of places, and needleleaf also decreasing in the northern edges of these Eurasian, European land masses, and in the drier regions where we had seen barren land changes before these periods around 60,000 years ago, and there are spotty changes here as well. But you can now see that this extends into Beringia and into the Americas as well, and C4 and C3 shrubs. So this is C4 and shrubs also show more colors, reduced aerial coverage of C4 here, increased aerial coverage of C4 here. So temperature and CO2 changes have to be looked at in conjunction with the MIS stadial, interstadials, and Dansgaard-Oeschger events. So you can see shrubs expanded quite a bit just south of the reduced coverage of the shrubs to the northern edge here, to the Arctic Circle. So again, take them for what they are in terms of how to relate these to what we have been talking about in terms of changes in hominin colonies, migrations, and timings of older colonies in East Asia compared to Europe of the modern human being. C3 grass aerial coverage increased a lot here, basically to replace the reduced C3 and shrub coverage, and you can see there is some competition there, and there are reductions of C3 over here and increase over here. What this means before the invention of agriculture is not clear, because C3 in general are trees, maybe more forest cover, but you have to match that with changes in broadleaf and needleleaf. So in the agricultural era, you would worry about C4 as many of the crops, wheat, rice, I think you have to be careful, I don't want to say things that are wrong, but many of the cereals are C4 types, so that may also be a player in terms of the resources for the hominins at that time. So barren ground area increased, so that's consistent with shrubs and C3 grasses. So you have to see how much this is related in terms of competition between various vegetation types themselves in a dynamic vegetation model. I think this is the last one, looking at barren ground coverage anomaly 22,000 years, 13,000 years, so we are already well into the deglaciation here. End of the last glacial maximum happened just after this, around 21,000 years, and then we were coming out of it, and then there was Younger Dryas around 11,300 years ago or so. By 12,000 years we were already quite warm, and by 10,000 years, of course, we were almost in the current configuration with changes in megafaunal population and beginnings of maybe agricultural revolution and so on. Okay, so 22,000 years ago, barren land expanded again in these drier regions now, but at the southern end you can see some barren grounds shrank here in the places that we have seen before. 13,000 years ago, similar in general. 12,000 years ago, again similar. Australia keeps on having a signal in this model, so one should go and check that, but I'm not going to do that. I'll just present the evidence of East Africa to show how complicated these problems are in terms of precipitation change, temperature change, humidity change, biogeochemical responses, and the net response in vegetation dynamics. We will get a sense of that from looking at the modern times, more recent times. Okay, so I hope you got a sense that climate has changed multiple times over this period, as we had seen before with the MIS stages 6 through 1. And here we translated that into landscape changes: barren lands, needle-leaf, broadleaf, C3 and C4 plants, shrubs, and so on. And there are all spatial scales and temporal scales of changes in each of these over Africa and globally. So hopefully somebody will go back and map the diaspora onto these vegetation changes more carefully, although it's always difficult to see whether landscape changes, vegetation changes, and desertification and barren land changes were the proximal cause or the ultimate cause of some of the big migrations and diasporas. So we'll and of course also conflicts between different ancestors of ours and interbreeding and so on. So I'll come back and add a podcast on East African vegetation just to give us a sense of how complicated these things are. Okay.